Okay, the second lesson we're going to look at is factorizing. Now you remember in the last lesson that you've just done, we did expanding, and we did something like 3 times x plus 1. And remember, we multiplied in the 3 into both terms, and we got 3x plus 3. Now, factorizing is simply starting with that answer, that 3x plus 3, and going backwards and factorizing out what's common and writing the brackets in again. So in this case, if I look at 3x plus 3, what would be common? The 3. So if we factorize out the 3, we divide both terms by 3, giving us 3 bracket x plus 1. Alright, this first method of factorizing is called it's basically just using a common factor. So looking at all the terms and seeing, is there a common factor that I can factorize out of it? So let's do, well, I'll call this one example 1. Let's say I had 5x plus 20. Okay, so I look at this and I say, what is common to both terms? So remember, again, terms are separated by a plus or minus sign. So I've got a 5x and I've got a 20. What is common to 5x? What is also common to 20? And the answer, of course, is 5. So if I write 5, then I write the bracket. I need to divide both of these. So maybe I'll write it in red. I'm going to factorize out of 5. I'm going to divide both terms by 5. Leave me with 1x, and I'll just write an x plus 4. So that would be the answer. For factorizing, 5x plus 20 would be 5 bracket x plus 4. What about if I had a common number and letter? So let's say 6x squared plus 9x. So this time, what's common to both of these terms? So we've got, if I look at the numbers first, what's common to 6 and also common to 9 would be 3. And then I look at the letters, what's common to x squared and to x? And the answer is x. So writing the brackets, if I divide 6x squared by 3x, I'm left with 2x, plus I divide 9x by 3x, that would leave me with a 3. And if I wanted to quickly test if I got the right answer, I can just expand it. So if I quickly look at it, 3x times 2x is 6x squared, and 3x times 3 is 9x. So I know that I've done it correctly. Alright, the second type of factorizing is called difference of squares. I'll write it as short form, difference of squares. And for this type, in this case, the word difference means to subtract, and squares means to actually have the term squared. So if I had something like x squared minus a squared, I've got a difference of squares. There's a subtraction between two things that are being squared. When we have this, the pattern to factorize is always the same. It'll be the term, without it being squared, plus the other term in the first bracket, and then in the second bracket, it'll be the term minus that. And because we have a plus and minus, it'll always get rid of that middle term. So there is, in this case, no ax term. And if you'd like, we can quickly do it in another color here. If I was to expand this out, I'd get x squared minus ax plus ax minus a squared. And you can see from this that this term right here and this term right here, minus ax and plus ax would cancel out, and that always happens with the difference of squares, leaving me with just x squared minus a squared. So let's try, I'll call it example 3. X squared minus 9. So maybe at first glances it doesn't look like the 9 is squared, but if you think about it, is there something that squared equals 9? And yes, there is. 9's the same as 3 squared. So this is really like x squared minus 3 squared. So if I wanted to factorize this, I would write x plus 3 in the first bracket, and then x minus 3 in the second bracket. Let's do one more like that. Let's see here, 25 x squared minus 100. Okay, this time the first term has two things that are squared. There's a 25 and an x squared. And you might notice that 25 is just 5 squared, and 100 is the same as 10 squared. So when I factorize this, I would get 5x minus 10, and in the second bracket would be 5x plus 10. Now that time I did the minus first, but it makes no difference whether I have a minus in the first bracket or a plus in the first bracket. When you're multiplying, you end up getting the same thing, so it's okay to put the minus first. Alright, the next type of factorizing we've got is grouping. Now grouping is when we look at it and there might not be a common factor for all of the terms, but if we group things together, we'll see that there is something to factorize. So for example, let's say if I had 4x plus 8 plus 5y plus 15. At first glance, you look over this, and there's nothing common to all of the terms. I've got a 4 and an 8. A 2 could go in, of course a 4 could go in. And then in the second group, I've got 5 and 15, which of course 5 goes into, but nothing common between all of them. But if I choose to group them, so if I choose to group this, the first two as a group, and the second two as a group, I'm able to factorize something out of it. So the first one would have 4 that could come out of it, and then I would get x plus 2 in the brackets, and the second group has a 5, leaving me with y plus 3. So that would be as far as I could go with that one, because there's nothing common after that. Alright, so we'll call it example 5. I could do an example where you could go one step further. So, if I had 3x to the power of 5 plus 9 plus 5x to the power of 6 y plus 15xy. So I look at it, and there's nothing common to all of the terms, but if once again we group it, the first two together and the second two together, I've got a 3 common here, giving me x to the 5 plus 3. And the second one, so plus, I've got a 5, and there's an xy that's common to both terms. So that would leave me with x to the 5 plus 3. Now you'll notice this time that what's inside the brackets here, x to the 5 plus 3, is exactly the same as what's in the brackets over here. And if we do that, we can now factorize out what's in the brackets. So it's common to both of them. So we get x to the 5 plus 3, and then what was left over, 3 plus 5xy. And then that would be fully factorized. So that one had one additional step to it. Alright, the next type of factorizing that we're going to look at is to deal with quadratics. Now we're going to look at simple quadratics. So a quadratic is written in the form ax squared plus bx plus c. And we're going to look at the case where a is 1. So you won't see the 1 there. So we're basically looking at ones that are like x squared plus something x plus c, but there's nothing in front of the x squared term. Alright, so when we're factorizing a quadratic, what we're looking for is, we're looking for what adds to the b value and what multiplies to the c value. So what two numbers would add to the middle term, b, and what same two numbers would multiply to c? So let's do an example with that. Alright, so let's add x squared plus 5x plus 6. So, what I want to know is what two numbers add to 5. So what two numbers add to 5 and what same two numbers would multiply to 6? So you think of numbers that will multiply to 6. So 6 times 1 is 6. 6 plus 1 equals 7. So that doesn't equal 5. That didn't work. Also 2 and 3. 2 times 3 is 6. And 2 plus 2 times 3 is 5. So there's the correct answer. So we want to use 3 and 2. So what we get to do in a quadratic is jump right to the brackets and put those values that I just got here, the 3 and the 2, and add them into the brackets. So bracket x plus 3 and x plus 2. Let's do a couple more like that. So example 7. X squared plus 9x plus, let's see here, 20. So this time I want to know what adds to 9 and what same two numbers are going to multiply to 20. So what multiplies to 20? 10 and 2, 10 plus 2 is 12, so that's not it. 5 times 4 is 20, 5 plus 4 is 9. So it's going to be 5 and 4. So what we get to do is jump right to the brackets. Bracket x plus 5, x plus 4. Sometimes, the first two I've done there are both pluses. So sometimes there's a minus in there, so let's try one like that. So let's add x squared minus 5x minus 14. So what two numbers would add to negative 5 and the same two numbers would multiply to negative 14? So we're adding to negative 5 and multiplying to negative 14. Now the fact that the two numbers multiply to negative 14, the only way you can get two numbers to multiply to a negative is if one of them's positive and the other one's negative. So I know one of them's got to be positive and the other one has to be negative. So what two numbers could multiply to 14? 7 and 2. So I just have to make sure it's the right way for them to add to negative 5. If I had positive 7 plus negative 2, that's positive 5. But I want negative 5. So negative 7 times positive 2 is negative 14, and negative 7 plus positive 2 is negative 5. So it must be negative 7 and 2, positive 2. So I can jump right to the final answer here and write bracket x minus 7, x plus 2. And once again, it doesn't matter if I put the x plus 2 first and then the x minus 7. It does matter where the plus or minus goes, though. I couldn't have x plus 7 and x minus 2. That wouldn't be the correct answer. Alright, so there's a few examples of different types of factorizing. We'll continue in the next exercise some other factorizing involving quadratics that are a little bit harder. But hopefully that's good to get you started on the next exercise that you'll be working on.